Hello, everyone, and welcome to our second Shifting Gears with SDV webinar. My name is Serena, and joining us today is Florian and Christophe, who will be presenting on the topic of high-speed prototyping with Eclipse eCAL. If you have any questions for Florian and Christophe as we move through today's presentation, feel free to ask them in the chat or ask the questions tab. Over to you.
Thank you. Let me share my presentation real quick. There we go. Then, thank you very much for the introduction, Serena, and a big welcome also from our side. It's a real pleasure for us to speak today in front of this awesome community. My name is Christoph Hannemann, and together with my colleague Florian Reimold, we are looking forward to dive with you all into the very first webinar of our middleware eCAL. eCAL, as you know, is a part of the Eclipse Foundation, and therefore we prepared a very exciting content for you today. And the content is structured in the following way. So we will start with the first introduction that will be approximately 10 minutes with a theory part. And the introduction is especially for all those participants who didn't hear about eCAL so far. And the second part is the more practical one. And also intended as the main part for today, where Florian will show us how to work with eCAL on your machine, respectively, in your project. But first of all, some words to the faces behind eCAL, Eclipse, and some historical background. As you can see, it is not only Florian and me that are the main project contributors of eCAL. There are actually 4 main developers that are actively working on new features and enhancement. Hello, Kerstin. Hello, Rex. eCAL was originally developed as a middleware for Continental autonomous driving systems. Continental, for those who don't know, one of the biggest automotive supplier in the world. And at first it was only an internal project. It was used for the software pre-development on high-performance computers. But at some point, we convinced our management that we can even gain more benefit in the project when we release eCAL as open source. And so we did. And eCAL became the first open source C++ project at Continental. And a few years later, we took the chance to become an active member in the software-defined vehicle group of Eclipse, and therefore we finally moved the project under the Eclipse umbrella. So as I mentioned before, eCAL was founded in a rapid prototyping context. When we start prototyping of our ID algorithms, we usually do not develop and test them on the later target hardware directly. Instead, we are using powerful standard hardware in wicked setups, which sometimes kind of look a bit like a big server rack, as you can see it here on the slide. And so in the end, the developer has the freedom that he doesn't need to care so much about the resource limitations for his software, as it's not an embedded hardware device. We can easily extend the hardware with, for example, more powerful graphic card for AI or camera applications, automotive bus interfaces like CanFlex, LIN, sensor interfaces, and all this stuff. Or we just put another high-performance PC into the trunk of our test vehicle, maybe with a complete different operating system that fits to our need. As you can see, we are scale resources horizontally and vertically, and in the end, the flexibility in scalable hardware enables the developer to save a lot of time, and with that, as a result, also money in developing new functions. But if you look a bit closer to such a rapid prototyping setup, it's not only one software component that is running. Instead, we have a couple of them. Nodes distributed on our heterogeneous RP hardware setup. With the hardware, we have different operating system, different platform architectures, communication protocols, interfaces, and so on, in order to bring all these distributed software nodes from our rapid prototyping stack together so that they can communicate between each other. We need a communication abstraction layer that is able to run on various platforms, various operating systems, on single hosts, as well as on multiple hosts. And in addition to that, we need a communication layer that has that fulfill requirements for high performance data of camera and LiDAR and everything that you have in automotive application. And at this point, eCAL was born as a high performance middleware for prototyping AD software. The following slide shows the eCAL in a kind of cross-section architecture. As I said, we need something which can run on heterogeneous operating system setups, and eCAL is able to do that. We support Windows and POSIX-based operating systems like Linux and also automotive-grade QNX. We have even support an experimental stage for macOS and FreeBSD. What we do then is that at the very low end of the abstraction, to abstract the communication protocols that the operating system offers. So for single host communication, we set on shared memory as it is the fastest way to exchange data. For distributed hosts, we utilize the network stack with UDP multicast and TCP. By the way, eCAL automatically detects what the most efficient protocol is, whether the software nodes are on the same machine or distributed on multiple hosts. In eCAL, we do not make any assumptions about the payload that the user wants to transfer. We just send a binary blob to the respective receivers. And if the user wants to offer his data in a more structured way with message definitions and fields, eCAL provides some convenience functionality for famous serialization protocols like, for instance, protobuf and flat buffers. All data, or rather messages, will be exchanged in a topic-based publish-subscribe pattern. Furthermore, we offer the user the opportunity also to create a client-server architecture, which can be very helpful for example, remote procedure calls, as you get back also a response message from the receiver in comparison to publish subscribe, where you just fire and forget. Both patterns are natively accessible from the user space via a C++ API, but the good news are we wrap C++ API also into other languages. Most famous one is most likely C and Python, but we have also support for C#, AmpScript, Simulink, and even Go and Rust from an external contribution. And yeah, on top, we provide very powerful applications for visualizing the data that flows between the eCAL nodes and something for recording, replaying traffic, and much more. Yeah, so for those of you which are fairly new to middlewares and data-centric communication approaches like eCAL, and I would like to add a few words more behind the terminology of a publish-subscribe pattern. So let's assume we have two separate hosts in our setup, and on each host are running different eCAL nodes. On the top host, we have a cam grabber and a lane recognition algo, and on the bottom one, a path planning algo and an HMI visualization. The cam grabber publishes the extracted image to the topic image. On the other side, the lane recognition algo subscribes the topic image and receives the outgoing messages of cam grabber port. So besides IPC communication, this also works with inter-host communication. So lane recognition publishes the lane infos to the topic lanes on the first host, and on the other host, path planning and HNI subscribers can receive the lanes. So both of them are able to receive the data at the same time. So as you can see, we have a communication pattern that allows a one-to-N connection or even an N-to-M connection, which is very efficient in distributing data. So far so good, but it's not only the publish-subscribe pattern why eCAL is an outstanding and state-of-the-art middleware and why you should use it in your project. I will provide you 6 good reasons for it. So the first reason is definitely that eCAL is completely message protocol agnostic. As I told you, when we support a wide range of serialization formats out of the box, but you can also implement your own one. Furthermore, eCAL, or rather the eCAL monitor, provides you the possibility to implement serialization and type-specific plugins to visualize the data live in an appropriate view. The second reason is eCAL is only a small library and not an entire system ecosystem like other middlewares. As it's a library, it's easily to customize for a specific build environment, and it integrates seamlessly into existing projects. So it's even so flexible that it embeds into very large software frameworks like ROS. We have even a ROS middleware abstraction layer for eCAL available. Furthermore, the high flexibility allows us to wrap eCAL into other programming languages. The third reason is that eCAL has a lot of powerful tools like for recording, for replaying, for monitoring that are available as GUI tool and also as terminal application, partly also as TUI application and an anchor as HTOP style for targets where no graphical interface is available. Some of the tools have even unique features like the distributed recording concept that allows you to record locally in parallel on multiple devices. There's also a nice video YouTube online from Florian that you can watch. And the next reason is that eCAL is a zero conf. So eCAL itself runs without additional broker to distribute the payload to your nodes. There's no static configuration at all required. So you can just download eCAL without reading the whole documentation first to find the right settings. And the good thing is, depending whether your node run on a single host or on multiple hosts, distributed eCAL will always choose the fastest transportation layer for you automatically. Yeah, the next good reason is that eCAL is a failure tolerant as the different nodes work in a loosely coupled pattern. It can never happen that a node, the crashed node deadlocks the rest of the system. So this is important. Imagine we're in our vehicle in the middle of a test run, for example, and the HMI node crashes and blocks the rest of the system, for example. This would definitely not acceptable. And the last good reason is why eCAL is a good middleware. Yeah, eCAL is incredibly fast. We're using the fastest IPC mechanism that are on the platform available and abstract them with only minimal overhead to get really the best performance on any platform. The latest version even comes with native zero copy mechanism, so that allows you to transfer payloads even faster between different nodes on inner host setups. So as you can see, yeah, there are a lot of good reasons for prototyping your distributed software stack with eCAL, or even switch your entire project to it. Anyway, you're very welcome to try it out. Just go to eCAL.io. There is an releases section where you can find the suitable installer for your operating system, or you can also just build it from scratch, from source. And if I haven't made you curious yet, I hope Florian can convince you with the hands-on on eCAL. Therefore, yeah, I'm handing over to Florian. Florian, it's your turn.
Yeah, thank you very much, Christoph. Then let's try if we can switch screens to mine.
All right. I'm looking forward.
All right. So. Okay, awesome. So yeah, hi, I'm Florian. I'm working on eCAL since, I guess, 7 years it's now. And today I'm going to show you basically how to get with eCAL from almost zero to an entire running system, including our own C++ and Python applications. So we are together now going to install eCAL because I have already prepared 2 PCs, 2 virtual machines here that don't have even eCAL installed on them. We are going to configure a little bit. Yeah, I know Christoph said it's zero conf. If you want network communication, you still have to make one configuration. We are going to do that. And yeah, I already said it. We are going to program a little C++ and a Python application and take a look. Okay, so let's start with installing and configuring eCAL. Before I jump into that, just wanted to show you the page that Christoph already mentioned, eCAL.io. It has a quite good getting started section here. So if you go to that and follow the instructions, you should be, it should be quite easy to replicate what I'm showing you now. Okay, but I'm going to show it without the documentation. So what I've already done is, let's start with the Ubuntu machine here on my left side. What I have already done is added the PPA, so a personal packet archive, to my sources list so I can install eCAL. But yeah, if you have done that, you can simply sudo apt install eCAL, and I will also install the Python binding with it. So it's Python 3 eCAL 5, so it's eCAL 5 because eCAL was already taken. And it will now install eCAL, and well, just like that, we have installed eCAL on Ubuntu. Same goes for Windows. I've already downloaded the eCAL installer on Windows. I will install it for all users. And as every good Windows user, I will just click next a couple of times and install everything with default settings. And then I will have 2 eCAL installations without very much effort. You could compile it yourself, but especially if you just want to try it out, want to get running really fast, then this is a way to go. Now, I said we have to configure eCAL a little bit because I want to have network communication between those 2 systems going on. And by default, eCAL is set to local mode. So each machine would only communicate with itself, basically. So there is one configuration file on eCAL that you will see over and over again. It is the ecal.ini file. And it's somewhere in etc eCAL, whatever, but you can actually, we have installed eCAL, so you can always launch the eCAL monitor. We're going to take a look at it in a couple of minutes, but there's also the configuration link here, so you can just click it and don't have to hassle with typing it in the terminal. So if you open the ecal.ini, there will be the network enabled setting. I will set it to true, save, close the file, close the monitor, and do the same on Windows again. Open the monitor, open the ecal.ini, and set the network enabled to true. Okay, that's the eCAL setting. We have to do one other setting, and both virtual machines are already in the same network, but eCAL uses UDP multicast traffic for the auto configuration. And neither Windows nor Ubuntu really knows what to do with that multicast traffic. You have to tell it where to send that traffic to. And on Windows, we will have to set a route on both systems. On Windows, we will have to do that from an administrative command prompt. We will configure the route, so route @-p, so it's persistent, and the multicast address that eCAL uses is 239.0.0.1. The mask is 255.255.255.0. And now I'm telling Windows where to send the traffic to, and that's my local IP address. So it's 192.168.0.10. That's just the IP address that I have assigned previously. Hit OK, and because it's Windows, we will now have to restart the system. While that's restarting, let's do it in Ubuntu too. Here's one thing that you won't see that often. This is something that you can only configure from a command prompt in Windows, but actually can use a GUI on Linux. So there is the routes setting here, and we enter the very same data that we have entered on Windows. So the address is 239.0.0.1. The mask is 255.255.255.0. The gateway, we don't have any, so 0.0.0.0, and the metric is just the most important metric, so 1. So we will always have that going. Okay, now that Windows is also has restarted, we can take a look if it worked. We can again open the eCAL monitor. It will not show very much at the moment. Let's also open the monitor on Windows. But what the eCAL monitor has is the little host tab here. So we can click on hosts and see if the systems find each other. So the Windows 10 machine already finds both of my machines, my Windows 10 and my Ubuntu machine, and the Ubuntu machine does the same. So the network communication seems to be working fine. So let's minimize the monitor. We will come back to it again. You will see that over and over again, the eCAL monitor. But let's actually start with some communication between eCAL applications. So we have some samples that are shipped with eCAL. They are pre-compiled. If you just install the pre-compiled binaries, you can just execute them. And our favorite sample is the person sample. And it is called eCAL sample person. And then there is a send and a receive. So let's start with the receive sample. So the receive sample will now listen to data, but there isn't any, obviously, because we haven't started the sender yet. So let's start the sender on Windows. eCAL sample person send. And it's sending now, and now it took a second. You will always need a second for the applications to match up, but now the Ubuntu machine receives the data from the Windows machine. And we can now come back to the eCAL monitor. I promised you we'll see that over and over again. And we are still in the host tab here. Let's check the topics tab. So the topics tab displays all the topics that are currently seen in the eCAL network. And okay, it's now grouped currently by process. So there's the person publisher on Windows 10 and the person subscriber on my Ubuntu machine. And if I expand that, there is the topic person. And one is in the direction of a publisher and the other one is in the direction of the subscriber. So that's how the data can flow from A to B. The cool thing is we can now not only see that there is a topic and what message type it has and the encoding and the size and a lot of other information, but we can also double click it and actually see what is going on in that topic. So the eCAL monitor will now actually subscribe to the data and display it in this tree view. So we can expand this here and we see the ID, which is the only thing that is changing, but it matches up with what is sent by the Windows machine here. This works for protobuf encoded data because the eCAL monitor can then dynamically deserialize the data and display it in this tree view. If you have your very custom binary format going on, which you can do, and there may be reasons for doing that, then you will only get this ugly hexadecimal view, which won't help you that much, but you can still see that something changes. So that's also sometimes a very good information. Yeah, so that's to the eCAL monitor. There are some other tools that are shipped with eCAL. And the second very important thing next to the monitor is the eCAL recorder. So let's take a look at that. As Christoph said, we have basically all applications as GUI and CLI applications, but I'm only showing you the GUI tools now. Okay, so we are now looking at my Windows machine here on the right. So this is eCAL recorder, also shipped with eCAL. On the left side, we have the topics view. We can see all topics that are currently in the system. At the moment, just one. If we had more, we could blacklist some, we could whitelist some, but yeah, well, we only have one, so we are just going to record that. We can, on the right here, configure where the measurement should be stored, what name it should have. We can set a description that is then saved to the measurement. We can see all the recorder instances in the panel below. Currently, we only have one recorder, and we are going to keep it that way. But if you have a very large system, it often makes sense to have each machine record its own data, and then you would launch multiple instances, and that one recorder controls the other ones. But at the moment, let's just keep it with Windows 10 and yeah, have that record everything. So let's just hit record. We see now down here that it is recording something, only this one machine. It's currently at about 7 seconds. Let's hit stop and take a look what an eCAL recording actually is. So let's explore to the directory. So an eCAL recording looks like this. It always has this eCAL measurement file. This doesn't actually contain any data. It's just an entry point for the measurement. The actual data is then stored to the to the directory with my host name and specifically to this file. So it's 11 kilobytes, not that much. There's not much going on in the system right now. But yeah, this is the actual data. But we can open this file and it will bring up this third very important application of eCAL, and that is the eCAL player. The eCAL player, let's maybe minimize this one. Okay, the eCAL player can, replay a measurement, replay an eCAL recording. It also displays all the topics or channels that we have in the eCAL measurement, currently only one. And it also displays the description here that we can set from the eCAL recorder. And we can let it loop and hit play. And now let's go to the eCAL monitor on my Ubuntu machine again. We can see now, if I check here, there is on my Windows 10 machine, there's eCAL Play GUI that is now also publishing the person topic. And if we inspect the person topic again, then I'm not sure if you can see it through the stream, but the value here is now jumping back and forth because currently both the sample that we haven't closed yet is sending to the topic, and the eCAL player is also sending to the topic. What you would often do is just not have any applications other than the eCAL player sending data to the topic and then stimulate your algorithm with the eCAL player. Okay, so far to the eCAL applications that ship with eCAL. I promised you we are going to make our own application. And I think a good way to start that, as always, is with a Hello World application. You can find that in the documentation as well, and we are going to complete it. I have already a little bit of the code implemented here. So let's open Visual Studio Code to have a little bit nicer environment than just a text editor, and drop. Does that work? Oh, well, apparently it doesn't. Okay, so here is my code. I will enlarge it a little bit. So let's get rid of the window. No, not of my Ubuntu machine. I wanted to have that a little bit bigger. Okay, just like that. That's good. Okay, so this is eCAL C++ source code. eCAL itself is written in C++, and so C++ is one of the main target languages, but we also have others. But let's just start with C++. So what you will always find in any application using eCAL is this line here, the eCAL initialize. This you will always have to call to make eCAL work, and you select this information, the Hello World publisher here. This is the node name. For example, the eCAL sample person send that we have started has person publisher set in there. So this is how our eCAL node will be called. And at the very bottom, you will always also find the eCAL finalize, which kind of cleans up eCAL. If you forget it, well, the operating system will do it for you, but you should still do it. And what we also have is just a loop that will, at the moment, just loop indefinitely, forever. Okay, but we want now to publish data to the eCAL network. And for that, we need a publisher. And we are using the most simple publisher that eCAL can offer, and it is the eCAL string publisher. So it's an eCAL string C publisher. We have as a type an std string, very, very primitive. We give it a variable name, let's call it publisher. And we have to choose a topic name here. And let's call it Hello World topic. This is the topic name that the data will be sent to. In the person sample, it was the topic person. Now it's the topic name Hello World topic. And just like that, we have the Hello World Publisher. And what I will also do right now is create a counter, so we have something going on that changes. So let's make a counter that is just 0. And while looping, let's now send something to the publisher. So we call it publisher.send. We choose a string which must be hello world, obviously. So hello world, and we add the counter just after that. And increment it. Okay, and well, that's the entire application. So let's compile that. I think we need to configure the CMake project first, and then we can build it and run it in a terminal. So is it running now? Did I click that? No, it didn't. Well, I have a plus too much. That's what always happens when you make something live. So let's try to build it again. Now it worked, and let's run it in a terminal, and it is running now. So let's go back to, yeah, you guessed it, the eCAL monitor and see if it works. And we haven't still closed a lot of eCAL applications apparently. But we also have the Hello World Publisher. So let's inspect that. We can see, well, Hello World, and it counts up. So the application is running. Awesome. Basically, that's it. What we do with C++. So let's close everything again here. Well, how do I terminate this? I will just close that. Oh, I mean, we could also just keep it running. Let's keep it running. What we have seen now in the eCAL monitor is the tree view, and we have seen the protobuf reflect. We have seen the tree view of the protobuf reflection, and we have seen the string reflection. So just displaying a string. We now want to have something a little bit more exciting, and I have already prepared something. The code is online. You can download even the binaries. What I have now already prepared is a small recording of a webcam. So we are now going over to images. So let's open this measurement here. I have just done that and hit play, and it now replays the recording. And if we now open the eCAL monitor and take a look at the topic, so it's the webcam topic here. This is coming from the eCAL player. Well, we see it's not very exciting. It's still just displaying, well, a tree view without very much tree items. But what the eCAL monitor also supports are plugins. And we are going to install one. We have available the webcam, the eCAL camera samples. And in that repository, there is, for one, the application that I used to create that recording of my webcam. And there's also a monitor plugin that extends the monitor with the ability to display images. So let's install it. On Windows, it really is a zip file that you open, you copy everything, and you just dump it in the binary directory of eCAL, which is in C eCAL bin. And on Ubuntu, we have a Debian installer. I will just also quickly install that here. So you can, it basically does the same thing. It integrates into the eCAL directory structure. So sudo dpkg-i and then the camera samples. And that now has the camera plugin installed. So we can now open the monitor again and take a look at the webcam topic. I will group by by another. I will not group by process here anymore. Let's group by topics. This is way better here. So the webcam topic, we have a publisher, we have a subscriber. So let's open it. And well, here it is. So it's me awkwardly waving in the camera. Well, that was just the best that I came up with. So, okay. Let's actually modify that image. Let's close it. And let's modify the image. And the most easy modification of an image that I also came up with is let's invert it. So yeah, let's invert the image. I already prepared something. I have the camera inverter prepared here. So let's now open Visual Studio Code again. But this time on Windows. You could do the same on Linux, really. So there isn't really a reason for me to choose Windows over Linux and any of this. Just do it by chance. Yes, I trust myself. I'm the author of this. Okay, so here is the inverter pie. So let me make this smaller. So again, here is the main function, or well, is it even a function in Python? I guess not really, but let's call it main function. And you may recognize this, right? So this is the eCAL initialize that we have seen in C++. It's now eCAL core.initialize. We give it, well, a name for the eCAL node. Now I chose image inverter. And I also created a publisher because we have seen that already. And we have also seen already how to finalize eCAL, very same thing. What we now have to do in order to invert my image is to actually receive it. So additionally to the publisher that we need later to publish the data again, we need a subscriber. Right, so let's create a subscriber, and in this case, it is a protobuf topic. So it is encoded with protobuf, and so we use the proto subscriber. We give it a topic name again. So it is webcam. I showed you that in the eCAL monitor, and we tell it which type we have, and the type is. Well, it is the same that we are sending. So it is compressed image pb2.compressed image, which transports a JPEG image. We borrowed that topic from the data type from the Foxglove data set. So they have created kind of a standardized, both for ROS and eCAL or whatever, and protobuf data set where they have different data types that you can use. So we now have a subscriber, and it would already subscribe something. We still have to tell eCAL what to do when it has subscribed something. And we do that with a callback. So we say sub, which is the subscriber, dot set callback. And we give it a callback. I already prepared that, and it is called, well, callback. And yeah, then this is the function that eCAL will call whenever data is available. So it's up here, and we still have to implement it. I just entered pass. So we want to send, well, the same data type with an inverted image to the publisher. So let's start with creating the data type, or an object of that data type. So let's call it inverted image. Inverted image or inverted camera message. And this is of type compressed image pb2.compressed image. We have seen that already. We can now set the data, so we already know that the type, so the format, is of type JPEG. We know that because I know, and we also have to set now, obviously, the actual image data. So inverted camera image dot data, and this is not with that we have to assign it. So sorry for that. We assign the image data in the function as a function parameter. We have the original camera message. So this is the not inverted one that we received from the webcam topic, and we can now take that, put it in my invert image function above here, and then set the result. So we assign invert image of the camera message dot data. Okay, so now we have prepared our message, and we now only have to send it. So pub dot send, and we give it the inverted camera message, save it, and execute. It is a Python file. Awesome. So let's hope that I didn't do anything wrong. Well, looks like I didn't. So let's check the eCAL monitor again. So we have the webcam topic here. This is the original. If I open it up again, it's still me waving awkwardly in the camera. So let's put it down here. And let's also check the inverted webcam. And now it's me not only awkwardly waving in the camera, but also looking creepy because I'm in inverted colors. And basically, I guess before it gets even more awkward or creepy, this is the end of our live demo. Thank you all very, very much for making it this far. And learning about eCAL. Thank you very much.
Amazing. Thank you both so much for your presentation. Is greatly appreciated, and your patience also for going through the little hiccup earlier. So thank you, everyone. We would like to encourage everyone that has any questions to put them in the chat or the Ask a Questions tab. I think for right now, what would be great is for us to also, sorry, the lighting here is just impeccable. The sun is just shining bright. But yes, if anybody is interested in shifting gears and wanting to present, please feel free. I'll link the form that you can fill it out and put it in there and express interest. We would love to have you. So there is one question here, and it says, how I use code IDE. Not sure if that is a relevant question. So
that question existed like 3 days ago already.
Yeah.
So I guess it's not about
so long before we start. Yeah.
Long before you started. Sometimes the audience pops in and just asks questions ahead of time to get ahead of it. So no, it doesn't look like there is any questions. So thank you both very much, and you have yourselves a wonderful day. Take care.
Thank you too. Bye-bye.
Bye.
Thank you very much.